Welcome back, folks. We're back for more. We're gonna get a network of resistors down to a single resistance. This one's gonna be a little more complicated, and not much else to say other than let's get to it. Okay, so here's your circuit, and ultimately we want to find a single resistance that we can replace this with, connected to nodes A and B. Okay, I left something kind of goofy going on in the center here. Current standards for drawing schematics don't allow this, but older schematics have it. If they're not connected, if these two wires are not connected, older schematics, you'll see it drawn with kind of a hop in the wire like that. That is not preferred anymore. If they are connected, they have a dot. If they are if they're not connected, they don't have a dot. I find it a little harder to read, honestly, but it is the standard, so we abide by the standard when we need to. But for now, I want to make it abundantly clear to you that this 12 ohm is not connected to the 6 ohm right here. So we want to start out with that. Okay, so getting this down to a single resistance. So we play the same game. What's in series and what's in parallel. So I gave you something to look at first. I want you to be answering these questions. Don't depend on me. It's a lot harder to make you do this when you're not in the room. I can cause a lot of awkward silence when I'm in a classroom, and I try to as often as I can. I'm not here to ask you prompting questions. But I can do it over the video, but it's really up to you to do it. So what's in series and what's in parallel in this case? And I hope that by now you've been looking at the circuit and you see that the 5 and the 1 are in series. Okay, so if these are in series here, right, we got to say, okay, I think they're in series. Do they share a node exclusively? Yes, they do. They share this one. Okay, so we can add their resistances together, and 1 plus 5 equals, I almost said 4. Holy cow. 6. 1 plus 5 equals 6 last time I checked. 1 plus 5 equals 6. So the combination is going to be 6 ohms. It's connected to the top of the 4, and it's connected to the bottom of the 4. That's a hint for the next one. All right, so I think I copied it. Yep, I did. So let's come down here, and let's get an eraser. I'm going to make it even bigger. There we go. So I can erase these a little quicker. Just like that. Okay, and we connect the equivalent resistance where the other two had been connected. Okay, so now this is going to be our 6 ohm. So that came down here. I don't know if that's a better way to notate it. All right, 6 ohms connected to the top and to the bottom of the 4. So they share the same two nodes. Now, you are correct if you were to go through and say, okay, those are in parallel. Okay, but I usually pause here and I go, is that all we can do here? Is that the only thing we can do? If you're really paying attention, is there another resistor that's connected to the top of the 4 and the bottom of the 4? Okay, so take a look now. Hopefully you see it. All right, and I'm looking for a resistor that's connected to this node. So my other options are this 12, because of the hop, and the 1. Okay, so it's either the 12 or the 1 that I can consider. If I move down here, I can say, well, what else is connected here? Well, the 6 is connected here, and the 3 is connected here, but the 12 is also connected there. So only the 12 existed in those two groups. Okay, things that were connected up here and things that were connected down here, the 12 is there. Okay, so if we want to maybe not cut and paste over and over and over and over and over and over, we got to look and make sure we're combining as much as we can in one shot. The 12, the 4, and the 6 are all connected to the same two nodes. Okay, so let's draw this a little bigger and say that all 3 of these are in parallel. Okay, and there's 3. Don't use the product over sum. That's what I wanted to warn you about, and here's where you're going to be tempted to use it because you got three things in parallel. What we do instead is 1 over 12 plus 1 over 4 plus 1 over 6. Now, do you trust my brain to do it? I don't trust my brain to do it. Maybe I do. But go ahead and calculate that any way you want to calculate it. And you find that you get 1/2 in the denominator. So 1/2 in the denominator, invert it, and you end up getting 2 ohms. Okay. Same kind of game applies where I'm doing my gut check. That 2 ohms better be less than all of the other ones because I'm adding paths of conductance. It's going to get easier, less resistant to the flow of current. So the lowest one is 4, and there's a 2. Okay. So that looks like that's going to work out. Okay, for that gut check, if they were all 4, I would end up with 4/3, which is 1.33. But they're not all 4. We got 2 that are a little higher, so we end up a little higher. Just kind of doing a gut check as to the range that we should find ourselves in, and I think we're there. Okay, so 2 ohms feels like a good combination to me. All right, so I'm going to remove those 3 resistors. I'm going to redraw the whole circuit here. Oh, this was the original. So let's grab an eraser, and I'm going to have to be a little more precise when I go to erase the 12 ohm. Okay, that's where everything else was connected. Let's see if I can scooch in here. Oh, that's not too bad. Okay, erase that. Forgive me if I don't get every last remnant of it. Oh, now I did it. Okay, that's okay. In this class, wire is cheap. You just gotta do that. Okay, that's still connected there. Okay, so all 3 of those, scrolling back up here, all 3 of those are connected to the right side of the 1, and they're connected down here to A. So we want to connect the equivalent here to the right side of the 1, and down here to node A. And that's our 2 ohm. Okay, that's where that came from. All right, by now I'm hoping you're getting quick. I hope so. All right. The 1 and the 2 are in series. 1 plus 2 equals 3. Okay, these are in series. So hopefully in your brain you can combine those and you can go, okay, now that's 1 resistor. It's a 3 ohm resistor. Okay, 1 plus 2 equals 3 ohms. And it's connected here on the right side of the 10, and it's connected down here at A. So not only are those in series, but I see the 6 ohm is connected to the right side of 10 and connected down here to A. And the 3 ohm over here is connected to the right side of 10, and the bottom is connected to A over here. So these all end up, let's grab a different color. These all end up being in parallel. Okay, so when they get simple and you can see things a little clearer, but this comes with practice, right? And that's what we're doing now, and that's what you're going to do on your homework. Then we can start to maybe skip some steps redrawing. Okay, so let's do the math on these. So we got 1 plus 2, and I'm going to draw it this way. I'm going to put it in parentheses, is in parallel with 6, and that's in parallel with 3. So this is 3 in parallel with 6 in parallel with 3. So it better be less than 3. And if they were all 3, 2 of them are 3, one of them 6. If they were all 3, I would divide that, and it would be 1. So it's going to be somewhere between 1 and 3. It's going to be a little bit above 1, I believe. But let's figure that out. So again, we have 3, so we got to be careful with it. Don't use product over sum. 1 over 3 plus 1 over 6 plus 1 over 3. So we've got, what is it going to be? 2, 4, 5, 6 in the bottom, and we're going to end up with inverting that and getting 6/5, also known as 1.2 ohms. Okay, so we take all of this stuff and we remove that and we redraw the rest of the circuit just the way it is. So here's the original circuit. Let's see if I can do this with a... Come on. There we go. That'll work. Now I'm comfortable doing that. And we can connect to the right side of the 10 ohm and down to A, our 1.2 ohm resistor. So that came from there. Do they share a node exclusively? They do. It's right here. And we can say that we connect those together. Here's B, here's A, and this is going to be 10 plus 1.2 ohms, also known as 11.2 ohms. All right, and there's your answer. One resistor, 11.2 ohms. So hopefully you're getting a little more comfortable with kind of the string of questions, the list of questions I ask when I'm trying to determine whether things are in series or in parallel, and kind of the steps I take in how to redraw it as I combine resistors into equivalent resistances to simplify the circuit. Resistors aren't the only thing we've talked about. We have other circuit elements. These are our only passive element, but we have active elements. We have voltage supplies, and we have current supplies. So the next videos are going to focus on when and how we can combine voltage supplies and current supplies. All right, so stay tuned and good luck.